Laws of chemical combination. Laws of chemical combinations. So there are basically few laws such as law of conservation of mass, law of definite proportion, law of multiple proportion, and law of combining volume, that is the Lewis-Sack law. So first is law of conservation of mass. So according to this, we know matter neither be created nor destroyed. The another definition, in a physical or chemical change, the total mass of the products is equal to the total mass of the reactants. That is, the mass of reactant and products should be equal. For example, let's take a reaction. Silver nitrate reacts with sodium chloride to gives AgCl, silver chloride, NaNO3, sodium nitrate. If mass of silver nitrate is 170, of NaCl 58.5, AgCl 143.5, and of sodium nitrate 85, then we have to add 170, 85.5. This should be equals to addition of 143.5 and 85. So whenever we add these mass, we get 228.5, and this is 228.5. That is, mass of the products is always equals to mass of the reactants. In the same way, let's take another example in which HgO on heating decomposes to give Hg and half O2. Mass of HgO 216.59 and Hg of 200.59, then oxygen will be of 16. 216.59 is equal to 200.59 plus 16. This also comes to 216.59. Now the next question is, suppose we are given AgNO3 NaCl, this will gives you AgCl, this is the first reaction, NaNO3. We don't know the mass of silver nitrate taken for the reaction, but we know the mass of sodium chloride, mass of silver chloride, and mass of sodium nitrate. Then we can easily calculate the mass of silver nitrate. According to this, X plus 0.585, this should be equals to 1.435 plus 0.85. Then X is equal to, this comes to 1.70 gram. The next law is law of definite or constant proportion. The definition is a chemical compound always contain same elements and their proportion by mass is always definite and constant. So let's take another example. Ratio of hydrogen is to oxygen by mass in water is always 1:8, irrespective of the sources of water. Now let's take an example. CO2 may be obtained by first burning of carbon, second heating of calcium carbonate, third by the action of dilute HCl on marble, but the ratio of carbon is to oxygen by mass in CO2 is always 12 is to 32, and in reducing form it is 3 is to 8. Now suppose burning of carbon, C plus O2, this gives CO2. Heating of calcium carbonate, CaCO3, this is the decomposition reaction, this gives CaO plus CO2, and CaCO3 plus 2 HCl, this gives CaCl2 plus H2O plus CO2. So in all these three reactions, carbon dioxide is obtained, that is the to obtain carbon dioxide method is different, but the ratio is always 12 is to 32. These are the atomic masses of the carbon and oxygen. Dividing by 4, this comes to 3 is to 8. This is the simplest ratio of carbon and oxygen in carbon dioxide. Now example, 0.5 gram silver is dissolved in excess of nitric acid. This solution is treated with excess of NaCl solution when 0.66 gram AgCl is found. So this is the first experiment. In second experiment, 1 gram metallic silver wire is heated in dry Cl2. 1.32 gram AgCl is formed. Now we have to show that these data confirms the law of constant proportion. So in the first experiment, mass of Ag is equal to 0.5 gram. Mass of AgCl is equal to 0.66 gram. Then mass of Cl is equal to mass of AgCl minus mass of Ag, mass of AgCl minus mass of Ag. So this will become 0.66 gram minus 0.5 gram, and this comes to 0.16 gram. Now we have to compare the ratio of silver and chlorine. Ratio of Ag is to Cl. .5 divided by 0.16. So this comes to 3.125. Now in second experiment, mass of Ag is equal to 1 gram, mass of AgCl is equal to 1.32 gram, mass of Cl 0.32 gram. Now again we have to compare the ratio of Mass of ratio of silver and chlorine. Mass of Ag is to Cl 1 upon 0.32, and this comes to 3.125. Again the ratio we obtain is same as in the first experiment. So this confirms the law of constant proportion.